So now we're up to UI state machines. You might want to review the YouTube videos where we established the session and login code. Not necessarily required, but it would help for you to understand what all is here. So when we first coded this, we established this login screen, and you can log in, and it comes in here, and once you're logged in, we have sessions on the server. So if we reload the page, it figures out that we're still logged in, and it actually prevents showing this, this middle part until it knows we're logged in. So there's several pieces going on here, and this is the perfect job for UI state machines. So let me review a little bit of the code as we had it. So even if you don't want to go back and watch that video, this might get you there. So when our application starts, we mount the app. We start our routing, which has to do with just the pushy, keeping track of this URL kind of thing. And then we load the current user from the server, and the server uses cookies to figure out if the browser that's trying to load this is associated with the person, and if so, it returns the valid user. And then we call this finish login mutation, which checks to see if the current user is valid, and if they're not valid, then it sends them to the login page. And then no matter what, it goes ahead and sets this root ready flag to true, and that root ready flag is used to show this middle part. And of course, this main router is the thing that can route us between the login form, the home, and the settings page. So technically, the router can get us to any of these pages, but we're making it so that unless they're logged in, they don't see the menu. So there's some stuff we're explicitly tracking here. So for example, we're going and grabbing the current user and seeing if they're valid to figure out logged in. That's probably okay, right? That's a piece of state that we have. It's very clear what that state is, and so this is declarative UI. We might as well use these directly to render things. So one of the core lessons that I want to show you, besides just showing you the UI state machine support in Fulcro, I want to indicate that you're already in a pure rendering situation where the state that's stored in your normalized app database might be sufficient for showing what you need to show. So the UI state machines are actually tuned. They're finite state machines, but they're tuned to the needs of Fulcro. So because Fulcro is a functional system with immutable data and a normalized state database, a lot of times you just don't need the UI state machine for things like this, because you have a very clear place to go and just ask, okay, is there a valid user? All right, therefore I'm going to do this. So in a system that were modeled purely with finite state machines, this state of being logged in would be one of many, many, many states in this like ever exploding finite state machine diagram, and you'd be tempted to use something like state charts, where state charts is a much more scalable way of doing systems that have large numbers of behaviors, right? It's kind of a scalable system of state machines. What I found, however, was that because you have this declarative functional system, you don't really need the full power of state charts. I'm sure some applications could benefit from it, but in my experience, the reason I went with writing UI state machines as finite state machines is, one, I didn't see an immediate need for state charts in my own work, and two, the amount of work to implement the finite state machines the way I wanted them was much, much less overhead. So, someday we might have a contribution library that does full state charts. But for the time being, I think you'll find that these work really well for a whole lot of your cases. And so we're going to go through converting this session-based code into a state machine, because there are some attributes here that would be nice to have. But I do want to note that I'm not going to model states like logged in necessarily, because I have a very clear piece of information already in state that represents that fact. So there's no reason for me to duplicate that in a state machine that's larger than it needs to be. So let's look at what we actually have. We enter the app, and when we enter the app, we need to figure out if there's a current session. So there's sort of a validating session state, right? When I start this load, that's kind of what I'm doing. I'm checking to see if the the state in question is good. And then I'm going to move to all right, I've finished checking that, and this ready flag really has to do with that, right? This ready flag is this separate piece of state that I invented just to track that I'm done with that step, right? So this is probably going to go away, right? That's probably something I could track just with a state I'm done checking to see if their session's good. I also have, if we look at the login component itself, right? So this stuff's kind of spread around in the login form. I have a couple of flags here. Am I in an error state? Is the thing busy? And if you go and look at how that's implemented, it's a lot of keeping track of things. And so this is exactly the sort of thing that could be modeled with different states, right? Was the login an error? I'm in an error state, right? Am I currently checking their credentials? Okay, I'm in kind of a checking credentials state. So there's some of this stuff that's going to be able to disappear if I were to wrap this in a state machine. But a lot of this other stuff works just the way it is. And instead of using mutations here, what I'm going to end up using are state machine events. So that's kind of the transform that I'm looking for. Now, the other thing I'd like to get out of this is there may be a case for, say, for example, having more than one kind of login form. And I'm not sure. Yes, actually, for the login form of my state machine, if I think about it, when I go to process a login event, I'm going to need this information passed to me. So I'm going to need a way of passing that sort of data. And there might be cases where I need to explicitly set state on a given component. Now, here's a cool thing about what we can do with state machines in Fulcro that you can't really do in other systems, and that's that we have normalized state. So any given component in my system has a well-known location in this state database. And so what I can do is I can alias component state locations and create a system whereby I don't tie my state machine definitions to the actual component UI, which will let me eventually be able to reuse these state machines. In fact, we do this in some of the larger apps that I work on commercially. We'll have a single state machine, say, for handling master detail CRUD interactions, right? Forms, where either you're creating something or you're editing an existing one, you're showing a list of them, you're hitting new. It's the same stuff over and over again, but there's different UI components involved, but it's the same state machine. The same state machine structure can handle the idea of, was this a new one? Am I in the creating state? Is this one that's dirty? Am I in the list route or the edit route, etc.? And so you can create kind of nice blobs of logic that can be carried along and associated with these. So those are the kind of goals. So let's stop being abstract and let's start porting this login stuff. So I know I'm going to have some states around this getting started. When I'm showing the login route, I'm going to have some states around, starting, the login process, whether or not I'm in an error state or busy. And then if I go and actually look at the session implementation, I can see that this login thing, right, if there's an error, I have to remember to set that busy flag to false, right? There's a little bit of bit twiddly stuff here that will go away. So let's start writing this. So the UI state machines, as you might guess, have their own namespace. And I usually alias that to UISM, just the first, kind of letter of each word of the acronym UI, user interface state machines. Okay. And there's a macro in here called def state machine. All this macro does is give your state machine a name. It's really a map, and it registers it with a global registry of state machines. That's necessary because the state machines themselves do need to refer to lambdas, so they need to refer to code. So the state machine definition can't be stored in your app state, but the state machine instance can. So as a quick note, if you notice this table right here, Fulcro UI state machines ASM ID, this is an instance of a running state machine for this main router. So just real quick, I could open up this router, and you can see it says it's currently routed. I can go to different screens. Well, we can see, if I open this up maybe a little more, we can look at the local storage of this state machine and see that it's keeping track of where it's at. It has some idea of a bunch of other stuff that we'll talk about as we go. This is a state machine because you can do deferred routing, and there are all sorts of timeouts and things. So I could hit something, it could be loading things, the loading fails, and maybe I want to abort the route, that sort of thing. So def router and dynamic routers in Fulcro actually uses one of these UI state machines to keep track of where it's at in a state machine diagram. All right, so we're going to fix our session stuff up. All right, so the first thing we need to do, everything is UISM aliased in this map, and that allows us to later, if we want, like make our own extensions or whatever, and just namespace them to your own space and reuse this map. So one of the things we're going to define here is the states, and there always is an initial state, and then it's got some sub stuff. So let's spell out our various states. So I'm going to have a state, and I'm going to namespace the states with the state namespace just to keep track of what's a state and what's not. Initial is hard coded as the place where this is your entry point to your state machine. So I'm going to have a state of maybe checking session, and that one is going to be used for my initial entry, I think. Let's think about this, because we kind of wanted our starting up and our actual checking credential. Can both of those work for what we're rendering in root? So if I were to say ready, ready sort of a separate kind of concept, isn't it? It's I've finished checking the session, and now I want to show the router. Yeah, that's a little different than I'm on the login screen and I'm checking whether or not I'm logged in. So I do need a separate state for that. So I think I'm going to have a sort of an initial checking session, and then I'm going to have a checking credentials state, and then I'm going to have a state for is this failed or is this error? This is probably some sort of server failed state, right? I need a separate state for what do I do? Maybe I'm thinking through this as I go. So initial state's going to take me to this checking session state. The checking session state's going to do whatever it needs to do that session check, and then if it succeeds, I might end up in a state logged in, but we said that's not necessarily something we need to track as a state, because we'll have the current user that says whether or not it's valid. So that's sort of a duplication of state, so I have to be careful and make up my mind. I don't want to denormalize my nice normalized database, right? So if I've got a current user down here that has a valid flag, then I don't necessarily want to duplicate that state by creating a new state in a state machine that stands for the same thing. So maybe I just want an idle state. We'll have to decide that here in just a second. That might be sufficient. So my session machine can be checking session, checking credentials. That's a little confusing. There could have actually been a real failure, and I could just be kind of done and waiting for the next command to come in. Okay, and I'm going to actually wrap these all down the line so this data structure doesn't get too terribly wide. Okay, so in my initial state, what you get, so one way of of dealing with this is in a given state, you can either specify a handler or a submap of the various events you expect to receive and what to do with respect to those. In initial, there's just a started event basically, and so typically what you do in the initial state is just do some kind of initialization sorts of things and then transition to whatever state makes sense. Now, in a handler, you're in an immutable environment. You're not actually side effecting. And this env, this is the UI state machine environment, the UISM namespace has a number of functions for manipulating that environment and giving you a new environment. So what this handler is supposed to do is return a new environment. If you don't specify the handler, then of course it's a no-op. And if you return nil, it assumes you didn't want to do anything. It doesn't actually screw the environment. But if you return a map from here, it should be derived from an env and should be something where you've called some UISM functions on it. So that typically the way you write these is you thread env through UISM functions. So one of the functions you can use is called activate, and that's just to move you to a new state. Right, so you can see I'm going to come in here and I'm going to go to the checking session. And then in the checking session, there are a couple of different events I expect could happen, and I'm going to just namespace these again by convention with event, just so I can kind of keep the keywords straight. And so when I'm checking the session, I'm probably going to get events like OK and error. And in this case, I'm meaning network error here, like the server actually said, you're screwed. And there's actually a target state. Keyword I can use for that. So that makes it kind of easy to trace through. But I could also just, I could do the same thing that I did up above and say my handler is a function of env since I'm kind of just connecting the dots with the events. And so then in my idle state, I might expect an event login. That's probably the only event I expect from in the idle state. And then in the checking credentials, going to have kind of the same thing as I had there. I'm making those two different states because they're kind of two different paths through the state diagram of how I want the application itself to behave. So I'm just kind of trying to track that separate thing. And I think I'm going to refactor this to checking existing session. Did I pre-code a login state machine? When did I do that? Okay, I'm going to delete that. Clearly I thought about doing this a while back and forgot I did it. Okay. So if I look at, I was trying to refactor this. And then here for the server failed, I'm probably going to have the same sort of support in a server failed state. You can try to log in. That seems like a reasonable event to accept there. All right, so if we go and look at the client, the first thing we're going to want to do is this load. Right, so we're going to want to take that load out of the main code and move it into here. So in my initial state, I'm going to have a load that takes an env. And so this looks very much like the load you would use outside, but it doesn't want to be tied to a specific class. And so here is where we introduce the actor models. And this is just for my own kind of informational purposes. UI State Machines currently doesn't actually do anything with this field or this entry. I'm just putting it here to kind of give myself a little bit of reference. So load can take the key or ident, so that's the same as what we had before, but then it can take a component class or actor name. Now in this case, this component class is down below me, so I could just move it up and use that. What I can also use is just I can say actor user, and now the session machine isn't tied to this particular UI component. I can later tell it that this UI component is currently standing in is that particular actor. And then I don't want post mutations. I'm not actually going to call post mutations here. What I want, if you look at UISM load, it says we can specify UISM OK event or error event instead. So you can see I can join this with OK. All right, so if that load succeeds, I get the OK event. If the load fails, I get the error event. And so now I've taken this logic that is tied up in my start and goes through this mutation here, and I've sort of gotten it out of there. I still need to put something here. It's going to start up the state machine and make it work. But I'm not to that just yet. I'm just trying to kind of duplicate the logic for the moment. All right, so I'm going to start that. I'm going to go to the check existing session. If I get an OK event, well, now I'm ready. I know that it's finished loading. And now I'm in the idle state. And the idle state, of course, accepts login. And yeah, I think that's reasonable. Okay, so if we get an OK, we go to idle. If we press login, we're going to handle our login. So I can just make a simple function for that, since it's the same in both cases, where I get my environment and return some sort of environment. Okay, so how's this looking? We need this finish login logic. So I'm going to pick that up, and over here, right, so there's something we missed. We're not just wanting to go to the state idle, we're actually wanting to handle this stuff. So if login just finished, well, this is sort of checking existing session. Right, so if we got an OK event, this is sort of the logic that we want to do, but we can encode it right here. Now this routing route to is a global mutation because where we're at in the application is a global piece of information. So I don't really need to deal with env in there. And then in terms of getting the current user valid. Now this doesn't really make sense in a reusable sense because I don't know where that thing lives, right? I know where it lives in this particular application, but if I were trying to make, say, a library out of this session machine, I couldn't rely on where this user actor is going to live in my application state, and that's why we have actors. So this is the purpose of the UISM aliases. So in here I can say logged in is the user actor's user valid attribute. Right? So that does tie me to the attribute being named something very specifically, but it doesn't tie me to, again, this UI component and this UI component's ident if it has one, or in this case it doesn't. And actually I'm going to change that because with UI state machines I'd rather just have the ident at this point because I can get to it easily. Oh, and I messed up my indentation again. Okay, so now because I've declared that logged in is going to be this attribute on that actor, now I can use UISM aliased value on env and just ask for logged in. So this kind of abstracts away how that particular thing is stored. And in fact, you can do derived state machines. Again, this is just a map, so you can pull this out of this definition, overwrite it with like an assoc in, and just change that to be whatever field you want. If you wanted to reuse this and the field wasn't named that. So when not logged in, route to login, and then this root ready flag I no longer need because the root ready I'm going to basically handle that by seeing if I'm in this checking existing session state, and if I'm in that state, that's going to mean I'm not ready. So I no longer need that at all. All right, so I'm going to be checking this. This is going to start. That's going to throw me into the checking session. When it gets its OK event, it's going to check to see if I'm logged in. If I get an error, I'm going to activate the server failed state. And now remember, what I'm going to redo in my UI here is this ready flag is going away. So I don't have extra state to manipulate. You'll also notice that down here I've got this show login busy, show login error. All that bit twiddly stuff can go away because now I've got that represented in states in the state machine, which means that the login mutation, which is normally mainly just managing those flags. I don't need to manage the flags. Don't need to manage the flags. Don't need to manage the flags. And I do need this returning with target kind of stuff. But we'll get to that in a second. Oh, actually my current user is going to cause me a problem if I normalize it that way. We'll get to that in a minute. I'm not going to need that action. So you can see I really don't need any local stuff except for this basic route to and detecting figuring out whether or not I'm logged in when logging completes. Everything else kind of goes away, and I am going to do a remote mutation of login, but the local stuff is kind of disappearing. So let's code that into our login handler. So handle login. Let's just take this up here. So handle login, hold on, handle login is starting the login process, and then once we're done, the user that we've got in app state will be kind of whether or not we are logged in. may want to give it, instead of normalizing this that way, I just want to do that. We'll normalize this, but we'll normalize it into a well-known location. Okay, and right now this is complaining because actions can't be empty. All right, so all login really needs to do when it's trying to be handled is really hit a remote. So UISM comes with trigger remote mutation. We give it an env, an actor that's currently on screen. So we're going to assume that if we're handling login, there must be a login form on the screen. The mutation, so we want to invoke the remote login in this namespace, app model session login. And then the additional mutation parameters. So login, options, and parameters. All right, so this has some UISM namespaced things for targeting things. So I, for example, target a specific actor, and I can specify, should be able to specify returning. Yeah, returning. So you have to be careful to look at what namespace these keys are in. Now, in this case, I do need to know the class of the actor I'm interested in. And then we were targeting session current user. We should probably continue to do that. And so that's going to be, I think we can just do plain old target. Parameters passed to mutation map also include additional state machine options. Oh, right, here it is. So in this case, I want an explicit target. I don't want to base it on any sort of alias. And so I'm going to use session current user. And then I'm going to thread that. This mutation won't trigger until I'm done handling this particular event. So get rid of this thing. And I think in all of these cases, the remote mutation, I'm going to want an OK event, same as before, and an error event. And then I think I'm going to go to the checking credential state. All right. So you can see we've kind of compressed all of this logic. Let me wrap this guy down so we can actually see the parameters. We've compressed this logic for all of this like general handling of the session into a nice compact form where we can kind of follow along with how it's supposed to work. Now, there are a few things we need to set up to get this working. Oh, we also need logout. So if I'm idle, there is actually another event I could get. that's a logout event. And I guess we have a logout mutation here somewhere that routes to the login screen and clears some stuff, and it is a remote mutation. So see now, failed checking credentials. It's really the only place logout should probably happen. Okay, so logout. See now, we handle everything with login. Oh, there's this route to on the OK. I think this is identical to this. So let's just we could just pull these up. Oh, and now that I'm looking at that, okay, yeah. So initial, you can have a handler or events. Most things are going to have events. And then if we have any sort of duplication, this is just normal immutable data structure stuff. So we can factor it apart and make functions that can be reused. Right, handle login is used in 2 places. Session result events used in 2 places. And I'm just using these to get some additional states because my UI kind of needs to rely on which of these states I'm in to be able to render correctly. Okay, so let's talk about starting this thing up. So I'm not sure I've got it all right, but this is some oh right, we were working on logout. Sorry, we don't have it all right because we haven't finished logout. So login, we got our OK event, does our route. Error event goes to failed. So OK goes to route. So login's done. We can get rid of that. And logout routes to login. And this is kind of a full stack thing. And I no longer need logout to be declared here. We're going to fix that in a minute. Okay, so this is the basic logic we're trying to duplicate here. So I'm going to thread through env. All right, so the first thing I need to do is this kind of global route to thing no matter what. So I'm just going to do that because that's a global side affecting thing. And then this is UISM apply. So apply action on an env is sort of like swap against state. So apply action takes a function of state, some sort of mutation helper, and passes state to it. So I've got swap state. So basically everything from here on will work unchanged there. the other thing I need to do in actor mutation and the params. So log out on this guy just had remote true. It was just like I've got no parameters and I just send log out. So that's really all I have to do. So that should be equivalent to the mutation I had before. Now, of course, this is now going to become, so trigger takes a state machine ID, and so in here I'm going to use app model session, so as the namespace. This is just an ID I'm going to use for the instance of the state machine I'm running. You can run more than one. So trigger takes the ID of a state machine, an event, and then an optional event data. So the event that I want here is event logout. And the change route here, I think I'm okay with. I don't think that's going to hurt anything. And okay, so I still have session over here as a namespace. And so now in the password field, this is now going to be UISM trigger. Is that what I called it? Yeah. So I'm gonna give this guy the ID of sessions. I'm not sure that that's the best name for this state machine, but trigger that on that, and I want an event login. And in this case, I need these parameters. So I did mess something up. So over here on event login handling, I need to pass these to the remote mutation. And same thing here. This is going to be a login. Oh, this is just the exact same. Code. So there's login, and then we're going to need to fix up the UI so it uses the state machine status. Okay, so let me go fix that problem that I said we have. So on login, we get parameters. So this end comes with event data under the UISM key. So when I get this, this is not login. When I get this environment, I've got this event data, and in this particular case, part of the reason why these have these namespaces on them is anything that's not one of these well-known namespaced keywords will be included as the remote mutations parameters. So I can just carry those along in the same map, and these kind of extension keywords that are local to targeting and returning and UISM event handling all get stripped out, but anything that I pass in this map that isn't known to UISM or its sub-facilities will end up being passed to the remote mutation. All right, so that ties in those pieces. Okay, so this is just a definition. It's literally a map that describes the structure of the state machine. And when we're running it, we actually need an instance in memory. And you can have as many instances of a given definition as you want, all in their own private current state with their own private data. And so that's what these IDs are about. So routers use their fully qualified class name as their ID. And in our case, we've used this : session and the session namespace as the ID. Now to get one running, you have to actually call begin on it. All right, so we don't need that anymore. more. Okay, so begin takes UI or app component, the machine definition you want to use, the instance ID you want to use, and then actors that you want to, real UI components that you want to use as the actors in the machine. So we're going to pass the app. We're going to pass the session machine's definition, the ID we want to use for this guy, and then the actors. So now you have to go look at the definition of the machine and remember, okay, we've got two actors, user and login form. So the actor user is going to be that session current user class, and the login form is going to be our login form from this namespace. Now, if these have stable idents, in other words, they only exist in one place in app state, you can just use the class, which is why I wanted this guy to have a single stable ident. If you don't have a single stable ident, then you have to actually use UISM with actor class and an ident that says where that thing's going to currently live. And so that's why I didn't want it to be based on the user ID. That would be a little bit finagly. You'd have to remap the actor during login. And so I didn't want to have to do that. So I gave current user a stable ident because it's just a one well-known thing. Okay, so let's see how far we are. I mean, this isn't going to work completely yet. Oh, and we don't need finish login anymore. So you can see we've cleaned up quite a bit of code here. We're not going to need the root ready. Well, but I want to leave the task mark because we've not done the replacement yet. And then this current user, that can normalize now, and that's not going to hurt anything. All right, let's just load it up and see what happens in state. I could care less about what's happening on the UI. All right, so we start. We should see ASM ID now has two machines in it. Here's our sessions machine, and our session machine is in the initial state. So something didn't happen the way we'd hoped. Looks like it didn't actually trigger the remote. But it did get started. It went to initial. There are no active timers. It figured out that the login form is there and that the user is there. And then we gave no initial state for, or we did. Session current user, oh, we didn't. But I think current user has initial state. I just want to make sure something's there in state for that at load. Okay, so now I've got session current user, which normalized into the session namespace current user, which says it's currently nobody and false. Okay, so that's all good. Okay. All right, our initial state. I think that's probably the problem. Yeah, checking existing session. If we look at our network, it tried loading this guy. This guy did load. It got foobar true, and then it stopped. Okay, so why did it stop? So it went here, it loaded, got an O. Did it get an O? Oh, UISM. So be careful about those namespaces. They'll get you. All right, so we'll reload. state machine. We're in checking existing session still. And it's useful, registering a board ID, it's useful to turn on debug logging here because it'll tell you what the state machine's doing. So it was loading this, doing merge, post mutation, trigger state machine event, trigger event OK on sessions with, and then there was just no event data. So it did hit event OK. That's this guy. And we're in, which state are we in? Checking existing session, session result events, event OK. Handler did a route. Oh, but we didn't activate our next state. We should be going to the idle state. Okay, so we ended up in state idle. Our session has our current user in it who's all good. And let's see now. I don't think did we model logout button yet? Oh, that's in the, yeah, that should be in here. Where did we put the logout button? It's in like the, oh, it's in the session current user. Ah, we did. All right, so let's trigger logout. That takes us to state idle. The session did not change. Oh, but we did it up here. So that sort of messed with us a little bit. All right, so we just did that. Right, so I changed how this worked. So session Q, this isn't where we put it anymore. This is going to be assoc in at, we in the session namespace, yeah. Session. All right, and I'm sort of stuck now because I don't have any UI working because I've not refixed the IDs. But now I went to idle, current user, and the current user is invalid. Okay, so that's kind of what I expect. Okay, so now we can fix up the UI with these various flags. So what does it mean for this application to be ready? Now, when you place actors in the system, it does queue refreshes. Well, it depends on what rendering method you use. With IDEN optimized render, as long as it can figure out the dependent data stuff, as long as it's direct data dependencies, you'll get a refresh. So what we're going to do here is we're going to make an ident based query here, and we're going to say I want UI SM ASM -ID, because that's the name of this table that these state machines go in. And then I'm going to use that sessions machine name. So this is saying I basically want to query the database for the status of that state machine. So I can just pull it in. And as long as I've pulled it in, actually, do I want to do that one or the table? Oh, you know what? It doesn't matter. I think it doesn't matter. We can just pull the whole table in. Right, so that gives root a data dependency on, you know, state machines changing in general. And actually, since I've stuck this in root, maybe I do want to query for just that one. And then I'm using this now. I'm going to refresh my memory on how get active state works. yeah, it pulls current state. So it doesn't matter how I query for it as long as I make data dependency. So I don't want root refreshing the app unless the state of this state machine actually changes. So I don't want the whole table. I want just that particular state machine state. And then I can use this, and this will give me back one of those, is it state whatever. Right, so as I render here, I say I'm in state idle. Okay, so when am I ready? I'm ready as far as this state machine goes as soon as I'm not in the initial or the checking existing session states. Right, so those are the ones that I don't want to find. So I'm ready, right, so now I can get rid of these guys. So I'm back to my declarative UI, and I've got my login form. Now in terms of logged in, I need to make sure my current user query is going to work right. Yep, that should be right. And that's why that was working before. I didn't really change how that worked. And so you see now this has become quite declarative in terms of not having to keep this extra piece of state around to figure out if I want to show the UI yet. Try the login mutation. All right, so it wasn't happy about triggering event login. User email, user password. Did we actually get a network attempt? We did not. Okay, so screwed something up with respect to that. Okay, so if I'm in the idle state, which I know that's where I was, and I click on login, then I go to handle login, that gets me the actor class, remote mutation, failure dispatching. Session current user is not, oh, target. Target has to be a vector. So just this error right here is what I was looking at. Anytime you see not iSeekable, it means you were supposed to pass something like a vector or a list or something, some sort of sequence, and you didn't. And obviously session current user isn't one, so that reminded me that targets are always a path, and paths are vectors. All right. So I didn't get any updates on this UI form, but you notice I'm now logged in. So I've got the ability to route now in the system, log out, take me back to the login form, and so I would like some feedback and such up, and I need to refresh the UI with respect to these menus because these menus shouldn't be showing if I'm not logged in. That was another. Oh, but wait, if I change the DB correctly, yep, at model current session user valid false. That should have hidden the menu. Okay, we'll diagnose that separately. I'll go ahead and throw a login for it. But the login form over here in session, yeah, that's what I thought. It was a refresh issue because it's considering it. Is it considering it derived data? Session current user. Yeah, that's just a missed refresh is all that was. We'll figure out that in just a second. So our login form is here. And so now we no longer need error or busy. We've already determined that that's no longer stuff we have to track. It's part of the state. And now we can derive them from the state machine. But we have the same problem as, or the same thing going on here as we had in root. We need to make sure we query for the state machine in question. I'm going to go ahead and just pull the whole table in. busy isn't defined. And then our initial state no longer needs these two, and that should clean it up. Okay, so same sort of exercise. All right, so when are we busy? We're busy in this case when we are checking credentials. And we're in an error state when we are in the state server failed, or the user is not valid. Oh, is that actually an error state? So we missed a piece here, right? There's the case of we got an okay response, but the credentials were bad, and therefore we want to show them invalid credentials. And then there's also the case of the server just barfed, and that's an actual error. And so we might need to expand out our state machine definition just to encompass those possible results. Because idle, right, we could have gotten to idle from this checking existing session, in which case the login form might not be on the screen. And if we go to the login form, we don't want it telling us our credentials are invalid. There's another thing we could do is we could change this state itself to be a better representation of what went wrong on the server. Because if we go to trigger this thing and it fails, that would be something we could actually store, or we could just actually store a different piece of information. So if the server actually failed, there was a network error, and so that's one thing. But in a login, if we go to handle the login and we got an OK event, then we could actually set an additional flag here to indicate that the credentials were invalid, right? So the server responded OK, but we can look at the state and see that, oh, well, we responded OK, but there seems to be an issue. And so here we can just add to our state machine another alias. And what did I just call it? Bad credentials is the actor user UI slash bad credentials. So then over here on, oh wait, I want that to be on the login form. Right, so I could add etc. So I'll clean this code up a little bit before I check it in for the video, but you get the basic idea of how to work with the UI state machines and where they can help you take logic that's kind of spread out and has a bunch of little fiddly pieces and concentrate it into this concept of a finite state machine that can control the individual kind of like where am I tracking of a particular collaboration among components.